Hey guys, welcome back to another video on the channel. In our previous videos, we explored prompting techniques such as chain of thought, self-consistency, and tree of thoughts. These methods significantly improve reasoning, but they still have one major limitation. They only reason using the information already stored in the model. As we can see in this example, when asked which planet has the most moons, the model answers Jupiter. While this was true when most of the training data was collected, it is no longer the correct answer today. This phenomena is known as hallucination, where the model generates information that even though sounds correct but is factually incorrect. To address issues such as hallucination and error propagation, researchers proposed a new prompting framework known as ReAct. ReAct stands for reasoning and acting. Unlike previous prompting methods that only focused on reasoning, ReAct allows the model to reason and interact with external resources at the same time. Instead of relying only on its internal knowledge, the model can search for information, interact with an environment, observe the results, and then continue reasoning. The core idea behind ReAct is the cycle of thought, action, and observation. The model thinks about what it should do, performs an action, receives feedback, and uses the information to decide the next step. So here we can see the entire pipeline by which ReAct works. So firstly, it analyzes the question of the problem, and based on that problem, it decides what information it needs or what action it needs to take. And on this basis, it takes the action, that is either searching Wikipedia articles or selecting an option from the available ones. So for this, they basically had a Wikipedia API which used to fetch the first five sentences of the article which we needed or which we wanted to search for. Thirdly, from the results it gets or the information it gets, it makes some observations and understands where it has reached. It then further continues the cycle of thinking, acting, and observing until it reaches the final answer. So, one thing which we need to observe is that for different tasks, we can differ the behavior. So, for tasks such as reasoning focused, we continuously require the model to think about its further action. So, we follow the standard thought action observation cycle. But for decision-making tasks which were common for AlphaWorld and WebShop datasets, we only require thought when it's necessary, and without that we just keep on acting. So we can follow pattern of like thought, act, observe, and then again thought. So basically AlphaWorld and WebShop are data sets. So AlphaWorld is a data set where you have to perform certain tasks like put the uh, cup on the table or any other task, and you have to decide action wise on how to proceed. And webshop is a data set where basically suppose you want to buy a bottle under $10. So that's how you are going to search and go forward with it. So that kind of queries are addressed in webshop. So for these tasks, you generally don't require to think after each step, but only when it's necessary. And the prominent feature is acting. So here is how basically React works in action. So firstly, we give it a query, and based on that query, it acts like what it needs to perform. Then after acting, it reaches an observation. Then it thinks on how it should move forward based on the observation it got from previous answer. And then further, the cycle is continued till we reach the final answer. So the question is, why does this React prompting technique work so well? So firstly, the model doesn't act blindly. Each of its decision is carefully thought upon. Secondly, as we are searching Wikipedia, we are much aware of what's going on present. So there is lesser chances of hallucination. And thirdly, As we saw in chain of thought, by breaking a complex problem into simple steps helps in bettering the responses of the model. So therefore, React framework works pretty well. So here we can observe the results on knowledge-intensive reasoning, where we took two data sets. One was hot pot question answering and fever. So fever is basically a fact-checking data set, like we give it a fact and we want the answer if it's correct or not. And hot pot question answering is a data set where you have to perform multiple thoughts to get to a final answer, like who is the current CEO of Apple. So first you need to go to the company Apple and then understand who the current CEO is. So what we could observe was that React was far better than Act only in all of these data sets. So Act only is basically where we just keep on acting and we don't think or observe on how we are acting. So React was better than this. And in chain of thought was better than React in hotpot question answering, but in fever dataset, React was better. And we could observe that combining chain of thought and self-consistency along with React gave us the best possible results. So how are these approaches combined? We will look at them further. So moving on to decision-making datasets, we could clearly see that for both Alford dataset and WebShop datasets, React was better than Act and any other for performing prompting techniques. So we could see that even despite not fine-tuning and only taking a few short prompting examples, we were able to train a modern React, which was better than a lot of cases like ACT or Butler or internal monologue prompting. So this is an popular approach which the researchers suggested. First was combining React with chain of thought and self-consistency. So there were two ways by which the researchers suggested how we could combine them. Firstly, we first use React and limit it to a number of steps. So like after step number 7, if it's unable to reach to the answer, we switch to chain of thought self-consistency learning internally. And secondly, if we first take chain of thought and self-consistency and we arrive at a final answer, but majority of the votes are not with the final answer, like n by 2 votes, then we switch to React-based learning. These give the best possible results among all. So even though React prompting works pretty well, it has a few limitations. Firstly, it's pretty slow. So like you saw the entire pipeline, it's very huge and it takes a lot of time. That's why it's not really useful for real-time applications. Secondly, error accumulation. So like if we get a wrong result from a Wikipedia or something which we actually don't want, when this gets accumulated and propagated forward, resulting is in getting the wrong answer finally. And thirdly, data dependency. So the researchers suggested that the quality of our response depends a lot on the quality of external information we could extract. So the better it is, the better our response will be. And finally, the repeated thought action observation cycle requires more computational resources. Overall, React was an important step forward because it showed that large language models become much more capable when reasoning is combined with interaction. And that's going to be it from my side for this video. If you found this video helpful, make sure to like, comment, and subscribe, and let me know how I can improve further. Thank you guys for watching it till the end.